Good morning, students. We'll start a new unit known as Environmental Chemistry. Students, you know very well about the environmental pollution. This is a very basic concept. The term environment means surrounding, and it includes the atmosphere, hydrosphere, lithosphere, and biosphere. Now, talking about environmental chemistry. Environmental chemistry is the study of chemical phenomena in the environment refers to the study of sources, reactions, transport, effects, and various chemical species in air, water, and soil environment. Students, in this chapter, the main objective of environmental education is to enlighten the people, particularly the students and the social workers, about the importance and the protection and the conservation of our environment and need to restrain the human activities which leads to release of pollutants into environment. So environmental chemistry is that science of chemistry which involves the chemistry, physics, life sciences, medical science, agriculture, public health, and study of all the sources, reaction, transport effects, and the fate of chemical species in air, water, soil, and their effects upon human activities. Now, pollutants. What are pollutants? Pollutants are substances present in a nature in a greater than abundance due to human activity. These pollutants are like lead, mercury, SO2, CO2, etc. Contaminant, a material which does not occur in the nature but it is introduced by human activity into environment affecting its composition. So contaminant is classified as pollutants and it has a very harmful effects. Receptors, the medium which is affected by pollutants, and man is a receptor of photochemical smoke causing irritation of eyes and respiratory tract. Sink, the medium which retain and interact with the long-lived pollutants. For example, the oceans are sink for the atmospheric CO2 and H2SO4 and ultimately damage. That is, see when sulfuric acid reacts with calcium carbonate. We know that about this incident of Taj Mahal. What happened? The limestone when reacts with the acid rain, it produces CaSO4 plus water plus CO2. So these are sinks that are the medium which retain and interact with the long-lived pollutants. Now, what is air pollution? Everyone knows about the air pollution. Any condition of atmosphere in which the presence of certain substances beyond certain concentration produce harmful effect on man and his environment. That is called air pollution. Air pollution is generally stratospheric and tropospheric pollution. Tropospheric pollution means, student, is a widespread. It means the main pollutants in this are gases, oxides of carbon dioxide, carbon, oxides of sulfur, oxides of nitrogen, hydrogen sulfide, hydrocarbon, and particulates such as dust, smoke, mist, fume, aerosols. And statospheric spheric pollution is mainly due to depletion of ozone layer and which may affect the plants and the human life. That is fauna and flora, right? And we know that air pollutants are of two types, students. Basically, we have five types, but the major are the two types, that is primary and secondary pollution. But I'll deal with the five primary pollutants together, that are CO, oxides of carbon, oxides of nitrogen, hydrocarbons, oxides of sulfur, and particulates part, right? So we know that what are CO? It is a colorless, odorless, and a tasteless gas, and 90 present heavy gas present in atmosphere about 96.5 and soluble, not soluble in water. Now, incomplete combustion causes this compound, and complete combustion causes this compound, as we know that. And natural processes like volcanic action, emissions, discharge, electrical discharge during storms, seed germination, marsh gas production, these all are responsible or for the origin of CO oxides, right? Significant contribution is from the human activities like transportation and agriculture, burning, forest fires, and industrial process. Right, students? So, incomplete combustion of fuel, volcanic eruptions, either it may be forest fire, waste disposal, combustion, power plants, iron industry, steel industry, these all are the major sources of CO, and coal combustion, volcanic eruption, and roasting of sulfide ore, sulfuric acid manufacturing, these are the oxides of sulfur dioxide. And what are the oxides of NO2? We'll discuss it. See, first of all, the particulates, pollutants, it is being given, it is in the air, and there are dust and soot released from the industries, and the range is given here. And particulates, the major source is suspending SPM, that is suspended particulate matter. Gaseous pollutants like power plants, industrial waste, oxides of nitrogen, and all these are very harmful effect on plants and humans, as we know. Now, these are some of the nitrogen oxides you can see. And when ozone reacts with NO2, it forms NO3. Again, it reacts with NO2, it forms N2O5. And N2O5, when reacts to water, the end product is HNO3, students, right? And we know that before daylight, NO and NO2 level remains fruitfully stable at the concentration. And as a traffic rush begins, it increases and level also increases. At midnight, what the concentration level increases, O3 build up, the NO level drops below 0.1 ppm. In evening, again the NO level goes up. This is due to again traffic rush, right? So basically the production of nitrogen oxides is due to this traffic rush, combustion of fuels, and that is the interaction of N2 and O2 during lightning, industrial waste, nitrogen oxides. You can see the nitrogen oxides. We have basically two type of nitrogen oxides, right? NO, nitrogen monoxides, and dioxides. So you can see the reaction during the daytime, how it increases the level of NO2 in the atmosphere when oxygen reacts with it. The level of NO also increasing, the level of NO2 also increases during the daytime. It is being shown here. Sulfur dioxide, oxides of sulfur is of two types, sulfur dioxide and sulfur trioxide. And we know that the end product of sulfur dioxide is H2SO4, that is a production of sulfuric acid. And natural processes such as volcanoes, sulfur oxides pollution distributed all over the globe. Main sources also, fuel combustion also, transportation, coal-fired power station. These all are the sources, as I've already discussed, of sulfur dioxide. And this is again responsible for the phenomena of acid rain, students. Now, these are some of the gaseous pollutants and their sources and their effects. As you know very well, already told you about the carbon compounds, sulfur compounds, nitrogen compounds, hydrocarbons, right? Sources are automobiles and petroleum industries, and you know the harmful effects of hydrocarbons. Similarly, SPM, suspended particulate matter, fibers, cotton and wool, textile and carpet weaving industry, which leads to lung disorder. Now, how to prevent the air pollution? We know the natural mechanism, that is dispersion, settling, and absorption, and artificial mechanism controlling pollution at source, construction tall chimneys, develop green belts, use only unleaded petrol, use petrol products with a low sulfur and ash content, reduce the number of private vehicles, plant trees. Industries should be situated outside, use catalytic converters, and control CO and hydrocarbons. We must control on the sources from which they produce, right? So these are very harmful products, and these are responsible for the acid rain also. One of the product that is called sulfuric acid and the nitric acid, which is being produced due to air pollution, that is responsible for the acid rain. So students, as we know, the oxides of nitrogen and oxides of sulfur, that is HNO3 and H2SO4, is basically responsible for the acid rain. This is due to photochemical reaction between them in the atmosphere, and it causes extensive damage to the buildings also, for the sculpture material of marble, limestone, slate, and these materials become pitted and weakened mechanically as a soluble sulfate leached out by the rainwater. And we know it very well, the example of an acid rain, that is the deterioration of a Taj Mahal, right? Now the main important thing in this chapter is, because till now you know all the things, the smoke. What do you mean by smoke, students? The smoke was proposed to describe the phenomena which occur due to condensation of some type of fog on the carbon particles, right? So, smoke plus fog together known as smoke, and it is of two types, classical as well as the photochemical. Classical smoke is known as London smoke or sulfurous acid smoke, and this smoke is produced from the gases like SO2, particulates, and in high humidity, students. And during winter season we see that, and it decreases the visibility. As you know, nowadays the condition of Delhi metropolitan cities, we feel a breathing problem there. People are facing a lot of problem, breathing problem. Asthmatic people are more. This is because of this smoke that is called a chemical smoke, right? Visibility problem is there. Irritation in eyes, nose, and throat is there. And photochemical smoke, it is known as Los Angeles smoke. This type of smoke is found by the combination of smoke, dust plus fog, with the oxides of nitrogen and hydrocarbons in the presence in the form of sunlight. Photochemical reactions are involved in this formation. It occurs in summer during daytime, and it is characterized by brown haze of irritating nature. It is oxidizing in character, harmful to the human beings, plants, and animals. So this all about the smog. We'll continue with our different type of pollution, water, soil, greenhouse effect, ozone layer, and the level of oxygen present in the water. Thank you so much. I hope you understand this concept. As this is a basic concept, you know it very well.